Good morning. We are Group 8 and our project is Inclusive Credit Scoring, predicting loan defaults with machine learning. We map this to two SDGs which are no poverty and reduced inequalities. My name is Srinivas and I am the leader. With me are Harish, Sarah, Desira and Hasya. And now Hasya will start with the background.
Thank you. Globally, 1.4 billion adults are unbanked and credit decisions are often inconsistent. Younger borrowers, women and lower income applicants are disproportionately rejected. Our setting is Home Credit, a lender for thin file customers. The users are risk officers and fairness auditors. The benefit: lower default losses and more loans for underserved applicants. 3 problems. Out of 307,511 applicants, only 8% defaulted, a severe 11.4 to 1 imbalance, so accuracy is misleading. Default rates differ by gender, 10% male versus 7% female, and by education, 11% lower secondary versus under 2% academic. We have to model around that bias, not encode it. 3 objectives. Identify drivers of default, develop a credit scoring model that quantifies disparate impact, evaluate the trade-off between accuracy and fairness. Sarah, on scope.
Thank you. In scope, binary classification on the main file, 3 DSPLC stages, 2 SDG mappings, and a fairness lens. Out of scope, supplementary tables, modeling itself, deployment, and any casual claims. We report associations only. 5 works anchor is Montoya 2018 set the Kaggle benchmark. Like GBM by K et al. Justifies our GA2 model choice. Hart et al. Define equal opportunity fairness, our key metric. Smoot handles class imbalance, and Bartlett 2022 shows fintech still discriminates against minority borrowers. That motivates our inclusive framing.
Hi, I'm Harish. So for the next part, I'll be covering the methodology. So the DSPLC has 5 stages, but for now we'll be covering the first 3, which are collection, cleaning and EDA. So we collected our data from a source called Kaggle, and the main file contains 307,511 rows and 122 columns with a default binary target. Why do we trust it? This is because real records from an active lender used in 7,000 plus Kaggle submissions, anonymized and fully documented. Following that is the data cleaning. For the data cleaning, we have 6 decisions. First of all, we dropped 49 columns missing over 40%, mostly housing fields. We kept extra sources 1 despite missing 56% because it is the strongest predictor. Following that is the median for numeric, unknown for categorical. And then we flagged the days employed anomaly. 55,000 rows had a placeholder of 365,243 days. Finally, we kept the income at the 99th percentile to remove data entry errors. So, in conclusion, we had a result of 307,511 rows and 75 columns with 0 missing. Thank you.
2 findings. On the left, severe class imbalance. Only 24,825 defaulters out of 307,511. So we'll use area under the ROC curve, not accuracy, plus class weighting in GA2. On the right, age. 20 to 30-year-olds default 2.3 times more than 60 to 70s. But age can't be a direct feature, and that's a fairness signal that we'll handle in GA2. 2 more. Education. Lower secondary defaults at 11% and academic at 2%, and this is a 6 times gap. EXT source features, defaulters consistently score lower across all 3. These are our strongest predictors. Asha on stats.
5 hypothesis tests. Chi-square on gender and education both reject at null at p less than 0.001. Well, t-test on EXT source 2 and age, and Mann-Whitney on income. All reject p at less than 0.001.
For ethical concerns, disparate impact will report equal opportunity difference alongside AUC. Proxy variables features like education, leak gender, so we audit them. Privacy, the data is anonymized, no PII. Transparency, our GA2 model will expose feature importance, not be a black box. Srinivas to close.
To close, we have collected, cleaned and explored 307,511 records. We have shown demographic and external score features that are predictive but carry fairness risk. Thank you very much for watching. We welcome any questions right now.